let's see.
I have experience in PD, so I can go through PD. So, so the thing is like for remaining guys who are up in the last class, so I think you all know like what I have explained to you last time. What?
EC.
So AC was like I have given few experiments. I said to make like 3 experiments. I think 2 runs. So anyone has done? Placement you haven't gone through. Then like why?
2 placement I have done, but it's mixed comments.
Placement, have anyone done the placement? No, that creating the bond and a group path grouping I have done. I have said now. So have you done that experiment?
So that is the problem. When he is assigning the work, it is your job to make sure to do the things. Other day you are not doing anything. If he is giving some work, the next day's job is to make sure you practice that. Right?
And that too, it's a small thing, so we can make them to make it now also.
Today after the class, give some assignment.
Like I think I have given with the comments also.
But 1 week, but last 4-5 days. Maybe let's say Saturday, Sunday, you take my classes. Monday, Tuesday, Wednesday, they should be occupied with some work. Let them all do. I'll make sure all the tools are installed in all the people. And their job is to make sure they do that work. Rather they reading that non-technical. See, theoretical thing, anyways you can cover. Within 2 days, if you read, everything will be covered up. But practically, I want you people to be practical enough that once you go to the customer, you should be able to do the work by yourself. You should not depend upon your senior. You should not feel that I don't know. If you show your pale face before the customer will simply say he doesn't know anything. Even though you are capable, he will decide that he cannot do the work. And he will definitely not assign you good work. The reason why he is here is to make sure that the basic things which are needed to ramp up the work is going to guide you. And until unless you practice that, you are not going to achieve. If you simply see the session and just forget, nothing will get into your mind. You practice that. Okay? Saturday, Sunday, after the sessions, he will give the assignments to you. Your job is to complete the sessions, assignments, and show him whether if you have any problem, talk to him and tell him. Okay, it's not like simply listening to his lecture kind of thing and just reading or putting something in the mind. But you need to do practically. That is what I am expecting from your end. Make sure you follow that. Okay?
And actually, so it's okay if you do the experiments or you don't know. That's not a big thing. That you can learn in 5 minutes also. So that's not a big thing. The thing is like why you haven't done. Like, have you feel any kind of difficulty like? You might have forgot or like comments might be like or else like you don't know like how to do placement in this tool at least. Like what are the problems you encounter like while doing that?
Not like that actually, we have some other works.
Some other?
We tried actually, but we didn't try manually because we checked out the things.
What all things you have to do? No, I am trying to say is that it's okay you forget. You have done that assignment or not done, it's okay. I'm just trying to understand what you guys are feeling. If today also I can give some assignment. So even that also like you might have missed something, you might have either Unix commands issue. Like you don't know like how to change the array and like already the placement is done, how to take the floorplan DB and all those things you might have some queries. So where you have like faced the issue, that's
we gone through all this. I mean, I opened already loaded section.
You have that saved database, you have it?
Yeah.
Can you open that? Like what are the things you have done?
Yeah, let me show you.
Okay, what are the things you have done? Open it. Okay, forget it. Meanwhile you open it. I just want to know like whether you have one thing I have said, copy the floorplan data, do the placement. Before doing the placement, you execute 2 commands. One is path group, and one more is bomb creation. So you were there. Okay, that's it. So bomb creation. Oh, previous okay. So those 2 things I have given the plot names also to you. So what you have like face the issue, like whether to use that command. I think I have in that history I have given a command also. I think command is also. So what you can do, like you can now this week you can do that. So the thing is like you go to database here. This is the floorplan DB, like in the floorplan DB, you copy, you make a directory. You type your name and then copy the floorplan DB there, and you load the floorplan DB, and you execute these two commands, creating the bond with the block names, like you take what else you want. But there should be some time for like start so two blocks, and then you execute the command and create a path group between some whatever say is, and then after example you just do place. That's it. So see the result and open one more terminal. In the don't do this don't execute command. Just do place off. Load the place off. So what the difference like through that blocks and that's a small thing. That's all. Now it's not so and now password VLSI DSI. Where is that Unix? This one only. So what you want to like what you want me to explain? Like today's what? High fan of instances. Okay. So high fan of instances. Okay, I'll do. So ఇది వేరేది అనుకుంటా. రామ్స్ లాస్ట్ టైం రాదు కదా ఇది. Open it. Middle button open it. Oh shit. ISIS అన్నీ ఉంటాయి. So yeah. So now what I'll tell is like I'll tell you. So it's just high fan out synthesis. High fan out synthesis is nothing new. So normally we have any cell like any like fan out if you inherit cell having a high fan out synthesis. So it will be like problem for timing and noising whatever. So you just need to buffer that. So what the tool itself. So ICC or counter has a command where like buffer is or some command is there. So we need to search it. So you know. So that command what it will do is like if a cell has a number of buffers now. So it will run. So I'll show you how to at least I'll show you in like high fan synthesis splitting the fan of a FSL. So I'll show how to split one or the other way, and I'll max like what are the ways it is there. I'll try to execute like all the ways. So before that what we need to get is like so we need to get what all the nets has I fan out. So that all we need. So how can we get like anyone calls like command difference? I think last time I said through command difference. ICC command difference. Okay. Anyone has known. Don't be like not asking like you should know that. But anyone has know because I don't know. So if you don't know any command, you can so and thing is like last time what I have explained to you is like if you don't know anything you can get those comments. I have explained way to like have you explained like how to get any comment if you don't know. So you can help. Yeah. So and thing is like what like we need to know what we need to get. So first fillers also placed. So the thing is first thing we need to know what we need. We need the nets which has high fan out. So through command I said like ICC without opening the GI we can do everything ICC. So without opening GI through by command line itself, we need to get what all the nets which are having high fan out. So how to report? So we'll check. Is there any command to report? Star net. So we have with the net option. So we have all the get net. So create a collection of get all the nets. So I'll remember that. I think last time I have explained about get flat net. So you remember that, and you go through remaining report net. So we have RNet. Okay, that's okay. So report net. Remove net. Sorry. And report net. So by this we can get any reports of net. We'll try like so and report report net physical. So these are things we have. Okay, that's it. So I'll do get underscore nets. So first I'll take some random net and I'll somehow find some fan out of that net, and by that command get all the like we can loop that so get all the nets. So let's take a net. Okay, let's take this net. Let's take this net. Report net. This. So what are the values it has reported? It is reporting some. Okay. No debugging down. Hey, this has some issue. A few memories doesn't have. LP location right. Milky Way location. So design open artisan ఈ ప్రాబ్లం వస్తుందా? లేదు లాస్ట్ టైం ఎక్స్ప్లెయిన్ చేసిన కదా. లేదు నేను గెట్ ఫ్లాట్ లాస్ట్ టైం వచ్చినాయి కదా. Cells. Okay, somehow it is okay. I'll do change underscore selection get underscore flat nets this net. So we'll go here. Control R for the properties. So here where is the fan out? Like to get any fan out. So number of pins. So if you see here to get any net fan. So this is the way you can like in analysis also how to go starting. So to know any fan what we can hardly get a net name. We'll select net name, and after selecting the net name, what all we can get, what all the pins connected to that net. I have given the command. So what are the pins connected to that net we can get. Later like the number of pins is like number of fan out. Number of pins, what all the net is connected, minus one is a driver, and remaining all are like, I think you got now. So this net has two pins. Number of pins is two. Two pins are connected to this net. One is driver and one is receiver. So if it is suppose it has some 10, some x. So one x minus one will be driver, and remaining all x minus one is a sink. So this is how we can get. We may have some other comments. Actually, I have used ICC long ago. Not long ago, at least bad. So I'm bad at comments. So we'll try somehow. The way we have, and we'll try. I think we can use all. This is all fan connected. So we have to do all connected. Return was flat nets. All connected. What it is like. So it will show what are the things it is connected for. So one definitely one will be sink, and one will be driver. So we'll do. So what we'll do? I think you all know tickle thing. I think. So we'll dump a script. We'll dump a file at least. So present directory. Alright. Fan out dot tickle. Find fan out tickle. So what we'll do is like So what we'll do is like first thing is like to get all the nets. So how to get all the nets? We'll do get underscore flat underscore nets. We have all these nets. We'll set this to a variable fan out or nets. I'll set a net. Net underscore flat nets. So when you do nets, if anyone this comment, let me know. I'll just explain. So I'm just doing puts. So this how we'll get like somehow it is. So for each we can do for each a dollar nets. Oh shit, command is wrong. For each So what the thing is here ICC is reporting as a bundle. It is giving a bundle number. So if you see here, I have got all these nets, and I'm setting it to a variable nets. It is giving as a bundle. So what we need like we cannot get it as a variable. So in that variable we cannot. So we need to find some way. I think there's an option for this. It's showing. So get nets all. So this will give all the nets. Somehow we'll try this command is reporting. So it's also reporting a bundle. So even for each also it cannot detect. So I think we have done way. Okay, we'll do for each a get flat nets puts $a. Oh, even these also including. Window report fan out. That's also star fan out. Set max returns all. Reports all fan out the objects. Hey, this DB. Even the other DB also we are getting this issue.
No.
Change the part. Rish. Understand.
వచ్చిందా ఇప్పుడు warning okay report all fan out set max fan out set port report net fan out okay report net fan out okay so what we can do is like flat nets select this right. So if you see here so this is a net and what are the pins it have. It has two pins. So it is showing it has showing two pins. So we'll see in the report. We have selected this net and how many it is reported as one. If you see here, so through this like report net fan out. So this command is reporting all the fan out of a net. So this is the net name and this is the fan out and this is like this like for now this is the number of fan out we have. So we'll dump into a file. Fan out nets fan out we'll do nets underscore fan out dot rp. Okay, let's open this file. gv hey, it has gone another gv file name into nets fan. So this is a file. How it is reporting is like it is reporting the net name and it is reporting the fan out. So what we need to do, we only need to get what are the like high fan out nets. So for suppose I'll take some 45. So it has 55 nets. So this we can size like we can do. So before that what we need to do is like by seeing manually you can check that like what are the nets we have, what are the like a fan out. This net has this much fan out. But suppose there are some, so it's almost 23k nets have been there. So in that which is a max. So how to know? So to that I think last time I have explained how can grab. So you can go through now also. So what you can do is like these all things like it's just info. We don't need I think. So I'll remove this. Okay. So I'll remove all these things. You can simply know this is the net name. This is the fan out. This C you don't need. What is that? C is an attribute. You can ignore that. So and capacitance and the driver. So for now I'll save this. So we have fan out at second column. So this sorry this vertical thing we'll call it as columns or rows. Column. So we have in the second column. So last time to print only the columns, given a command like anyone have remember. So okay, I'll remove arc range $0. So arc what it will do is like last time I have explained. Arc what it will do? It will take one line from like all these guys like new. So I think arc command you are new I think. So it's definitely. So what are the syntax? Like last time I not explained syntax. So arc is simple. Arc and this thing is colon and flower bracket. This is mandatory. And it has to be closed with colon and like flower bracket and that quote single quote. That is mandatory. And the file name is mandatory. So if you find the file name at least from a pipe we need some output. I think from a pipe you know I think. So what I'll do is like so like this we can get and with cat net span out and pipe to here. Like this also we can get. So arc needs some inputs, a data. So it should not be from a file. It can be from a pipe. I think you guys all know. So what do is like whatever the output from here na, it will send it to this. So and the no like only for arc. So we'll come back to arc. The thing is like arc syntax is this and the print $0. Print itself is just print. And in the arc command. So what arc treats is like give any file. So first it will hold the file. And in that file it will separate the fields based on spaces. So space or tab whatever meant based on space. Single space is there it will field. So this is one column. It has a space. This is one more column. It has a space. This is one more column. And so that's how arc treats one from a line. So if it has any number of spaces, then it has n plus one columns. So it has 1, 2, 3, 4. 4 spaces. That means 1, 2, 3, 4, 5. 5 only. Yeah, 5 columns. So that's how. So all differentiate line from spaces. So if we want to read full line. So now what we want is like we want only second column na. So I'll do 2. Only the second column we had got only second column. And somewhere here we are missing the number. We'll look into that. So we have only the second column. Why? Because arc has already differentiated based on separated those line spaces. So it will print only the second. So if you want to like two columns, two and the fifth one like fan out and driver. So then what it will do is like comma $5. So it will print first second column and the fifth column. So you guys have seen our spaces. So here even we got even the column is also empty for this. So we need to note. So we'll check why it is. So this file we'll go and check. So it is here. It is because it is printing the net name and the fan out is in the next line. So that's why. So there is no column for it. There is no second column. Only $1 it has. After the space it is new line. So it will not print. There is no column 2. That's why we have got space here. I think you have understood. So that's how. So somehow the net is here and the fan out is here. So what we'll do is like for now we'll ignore. Okay. So we have got. So if it is $0 na, it is full line. So $0 full line. $1 is first column. $2 second. $3 is that's and it should not be there. Suppose I'll $10. So it need not be there in that file. It will just not print nothing. Like doesn't have anything. So for now what I want is like column 2. So we have got all the nets which have like all the max. So what I do is like then what we need to do? We got the numbers. So what we need to do with that numbers? We need to sort on that because we have 1, 2, 3, 4. Yeah. So that we can get the max. So what I'll do is like I'll do sort. I think you know all guys. Pipe. What the pipe will do is like Pipe is a special character in shell scripting or in Linux. What that will do is like in shell scripting, the unit itself, unit in Unix is that the Unix command itself is a script like a script also we can use. So in a tickle, if you want to execute one by one multiple commands, we need to type each by each. And after executing the first command, we have to execute the second. Like in the terminal if we want to execute. So if I do TCLSH, I'll show TCLSH. So it will take us to tickle shell. So if I do set B and I have to do some operations on that B. So we need to execute one by one. The beauty with this Linux is like this is the only language here like this. It can execute the pipe. You can give a number of commands with this data. So first what I'm doing I'm doing the cat and net name. This is file name. So all the data in this file name is going to the next command. So it is processing that all this file. It is processing these lines and what it is printing only column printing. And in that we are doing sort. What else we can do is like simply we can do WC. So it will only the count. This is the number of lines. So that's how. The pipe command is special character which takes the input from the like one command to next command. So we don't need to give. So for the if this pipe is not there now. So why I'm saying that pipe has a script like and this it is like a scripting because if that pipe is not then we need to cat that file name. We have to store in the file name. Then we have to process that file name to awk. Then we need to read all the column stores. We have to store in one. And we have to give that file name to sort. Here we are giving sort. It has done with one pipe without like going through all these files. So that's how. It is like one line of scripting. So that's how. So have done sort. Nothing we got. Why we have got nothing. LASS. So we have something. And when we do sort, I think it is sorted based on spaces. I think. We have lot of spaces. I think. What will do? Page up. Yeah. What it is doing is actually I'll explain why it is showing empty lines now. So shut. Sort what it will do is like by default ascending order it will sort. So the thing is like we have spaces here now. We have spaces here. So this has a highest priority. So the spaces are being printed initially. So because there are many spaces in the design. So it is printing all these spaces in the top. That's fine. So if I do sort less now, all are I'll somehow say even if you do more like you can get only the spaces. What I'll do is like sort hyphen u. So all the spaces will be like unified to one. So we have got only one space. So this one might be repeated 100 times. Previously we have seen find out like 100 nets. But if you see one is for only one. Like one is only one time because we have done a sort. What we want is the max fan out net. That's it. So what is the max fan out net is 201. And we'll see. So what we can do is now we can sort. Rn. R means recursive, R means reverse, N means numeric. So what I'll explain. N means so we have all the numbers different like not in order. So what sort N will do is based on the digits it will sort. So 0 1 2 3 4 5. So that's how it has sorted based on the numbers. And we want the top one like first relation in the bottom. So we want that on the top. So what we'll do is like we'll do reverse. What we'll do is like instead of ascending we'll do in the descending order. So what we have got is like 661 is the highest fan out net. So we have 661, but we need to have that net name. Where we can find the net name. So either we can go to this file and do 661. So we can get. This is the net name. This is the clock pin. So clock pin by default it should not have because this is place DB. It will have before the place before the clock building. What it doesn't have any buffers between the clock to the flops. It will just do a like nothing. So this can be accepted like this can be accepted at place stage for clock nets. So we'll ignore that. The next step. So what is the next highest? It is like 480, 423, 254. So 254 is here and 480 is here, and this is also a clock pin. And 201 this is also a clock pin. Before place we can have clock nets it will have all the flops as a fan out. So this means this clock is showing 480 fan out means this clock is driving 480 flops. That's it. Before after the clock synthesis that clock pin or the clock will drive only one buffer or like hardly two buffers after the synthesis. But before the clock synthesis it will drive all the flops. So this can be accepted. So the next highest we should ignore the clock. I think you have all have idea why we are ignoring the flops. You have understand because clock synthesis has not done. So in the clock there will be no buffers. All the flops will by default connected to that net only. Clock net only. After clock synthesis, CTS we can do something. So we'll take 60 as the highest. So if you search 60, so this is how. Yeah, I'm expecting these only. So we have many things. 60. So we need to get only the column where the fan out is 60. So what I'll do is like so you got point now. Here the next highest fan out is 60. When I'm searching for that 60, we are getting all this data. So we need to somehow sort it. What I'll do is like we have got like whatever the fan out what are the nets having fan out, we need those nets. What I'll do is like instead of all these two, here it's last time I have used some if condition and I remember. So if what we should put in this condition column 2 equal to 60. So column 2 equal to 60. Sorry 60. Then we need that full line we need. I think in a day you cannot learn awk, but for now at least understand this command itself. Understand this itself. So in the industry you can replace whatever numbers you want. Either the column or the number or like you want the column 2. For now it will remember that command. So that's it. So whatever the wherever the column is 60, it is printing that line itself. So that's how. So that's how we need to. This is the reason why we have to learn grape all those things. So that's all. So we'll fan out. We'll do buffer tree synthesis for this. Okay. There might be some other commands, but have long ago used. That's how. So in the industry now, if your man gives something data to you. Don't to ask like multiple students to come. You ask some other colleague or find solution like you need to break. What I have even I don't know comment. What I said. So to buffer tree synthesis, high fan out. You need to get the hyphen out. To get the hyphen, you need to first get the net, get the fan out. So that's how we need to split it and we need to do. Procedure is not important. It is not like school like college step by step to write all the maths questions. Then you input is this and output is this. So in between whatever you do, it's up to you. The smart way is like either we can do this. So if you know sort all the things now, it will be this much. So if this is you don't know this, then you need to go all the one by which has the channel and all the things. So that's all. Or else you need to the fan and all those things. Okay. So I'll select this net. Change underscore selection. Get a net under flat nets. So what's the fan out of this 60? it is before place na. At least logically I can do. Control if I do control shift P, it will get the pins. There are 161 pins. Why have 61 pins? One is driver. So we can see here we will get the list from this. So all the like this direction names whether it is input pin or output pin. So all will be in except one will be output. So that's the driver. So this net I'll do. Okay. I'll think. So control shift. This is the net. We have got the net. So SYN. PC not. Because I don't know that buffer is command because I used to do it manually. Add buffer node create. Okay. Add buffer can do that something. So somehow add buffer. That's it. So we have one cell. I think you have logical idea. You have. There is one cell, and that we have 60. We just need to add buffers in between. After this cell, we need to add two buffers and split that. And this buffer will have this buffer will have, and 30 is acceptable. So if not 15 is acceptable, then again this buffer needs to split and this buffer needs to split. I'll somehow tell you. So this is the way. If you don't know anything, you just need to do the steps and do one. So hardly we have buffer addition need to do. So we have add buffer and route. We have insert buffer. So insert buffer I think you all guys know. Add buffer and route I'll explain. So add buffer on route is a command which is used at least this because now they cannot use add route. So you know this command add buffer on route. This is most command. If you use it, so what that is after the routing. So previously I have done ECOs, have shown you ECOs. So where I have added a buffer, where I have added a buffer randomly. But suppose that net is routed. Suppose this net there is a going from here to here. Like routed. So if you do insert buffer na, it will randomly add on that. So what it will like? It will randomly add on that somewhere part. And what it will like whatever the right it has present. Suppose we have anything. I can show. So suppose if you think this is the same. So this is the driver. This is the driver, and that is the same. Here that is the same. So what add buffer and route is like it should be routed. Before you add buffer and route, you do on this net. It will not be the error. I'll show. Buffer and route, whatever the net we have. What is the net name, man? We'll give some F1 okay. Location. These are all things I'll relate later. Okay. But for now, add buffer and router. Buffer and route will not like pre-routed. It has to be routed. So we do insert buffer. If you do insert buffer on this, what the syntax of insert buffer? Insert buffer. Either a net name give and the master segment or insert buffer pin name. Either the pin or the Z. If we have here and if we Z add here. By default, place on init cell. Where the pin on multiple place on that and then we move that cell to somewhere like near to base or normally here is a driver here is the same. So if you do insert buffer, it will add on here. But for a timing for anything, we need a buffer next to this buffer. Already the cell is here. We don't need the buffer close. It should be either middle or this side or this side based on right side. So it should be middle or somewhere. What buffer will do is Insert buffer add on this pin. What are the things we have to add buffer on what it is doing. We can specify add buffer on router. So I'll show the okay. Add buffer on what it will do. Note on this command. After this I'll open the router and I'll extend this. Okay. So what you do if you find the space here and if you want the buffer here, then it will add the buffer itself here only, and then it will see this net, and after splitting it will change this net and this net. It will add on this and change whole net name to one net, and that net name is floating. The other net is there. Some A pin buffer one is there. Buffer 2 is there. We are adding some buffer. So we have buffer 1. We have buffer 2. In between we are adding a buffer. So what the buffer will do is like add either on this pin, and it will make the from this A pin to here Z pin will connect. And from this from this pin to this A pin will connect. I think you guys know. A buffer will have A pin. Z pin. This Z pin will go an input. A pin, Z pin. A pin, Z pin. So insert buffer what it will do is add this cell and it will make this net as floating. And this like whatever the net, this whole net is there with this net name it will change. Or else if you give this pin, so what it will add buffer here. And it will make this Z to A net is not it will be floating like this. And what are the net available here? It is like it will change these all the shapes, vias. So it will change that to this net name. We don't need actually we don't need what we need is like we need to add a buffer here and change this net name whatever here is there and many whatever we have here, so that we can optimize in the next when the round it can round only here. You can just correct this, that's it. So I think we want the different green and buffer. So for now round add buffer. So I'll show. So for now topic to one thing. What I am seeing guys. Okay, insert buffer will do. So we cannot do add buffer from router. Will do create buffer tree. So we have man create buffer tree. So what it is like pin is incremental relation. It just this command will be like create buffer tree. Create a buffer tree for each player. Okay, this is itself. So this command itself will do create buffer tree, and from so we can give that pin. So what that will do is like it will create a buffer cell for all the remaining outputs. So we'll execute this command and we'll see. Okay. The create should be we have options. I can from we need to pin list whatever pins and create buffer tree hyphen from. So whatever the net we have we'll give it to these. Let's see what it will do. There are in the complex elimination. Okay. For this command like some conflicts in the library. So that's why we'll do insert buffer itself. Insert buffer. So we have the net name. So I'll do cat man. So what this insert buffer will do is like it will just insert a buffer. I'll show here. So this command adds a buffer or a inverter pair in between those. So what it will add is like if we add buffer, it will increase one buffer. If we add like a inverters na, it will add two series. It will not in the parallel. So what we'll do is like first thing is like from this control we have all these pins. We'll get these pins or else what I can just get underscore selection. So we have all these pins. What I'll do is I'll take all these pins into a file. We need to do buffer this. So we'll have pins dot txt. What we can do is like I haven't saved that file. So these are all the lines I have. What I do is like I'm trying to add new line on the spaces. So this file like what are the file we have is like as a continuous space separating. So now we have with what all things like we have separated new line. So line by line all the pins. So we'll split these cells by either 30 or either 15 or whatever it is. So what we'll do is like I'll change this. Override it to pins.txt. If we do pins.txt, oh shit. Same file. So I'll change this to file name pins underscore 2.txt. So we'll open this file. So what we want. So we have all these sorry, is the end. Okay. We have all this like pin list. So what we can do is like to insert buffer and the like what are the wherever to add now. We'll split as 15. So 15 buffers will add it to one buffer and 15 to 1. I'll show how. So from this buffer to we'll take from this buffer to this buffer. Suppose it is 21. Okay. I have taken 21 pins. What I'll do is like I'll add space /g. So I'll take all these cells and what I is like first of all I need to get a buffer name. So I'll get a buffer name. How to get a buffer master name? Get lib cells star bf. I think last time I have explained this command. So insert underscore buffer. So what it is expecting the object and the buffer lib cell name. So what I is like buffer lib cell name. Which buffer I need to add? This is okay. 4 drive strength. Or else is there any big buffer than this? Okay, I'll add 4 drives in buffer and pins it is expecting. So what all the pins I'll give is like I'll give all these pins. Sorry. So at least I'll take from here only some random number of cells I'll take. So till here I'll take. I'll give as get. Sorry. Insert buffer. What do report? Sorry. Insert buffer and the what are the cell, what are the pin it should add and the buffer name. So let me it is adding. Okay. The thing is like so class B. So that's how Z pin. So where we need to add buffer, we need to add Z pin. So we'll take Z pin here. Okay. This is our Z pin. So to this we add a buffer. Insert underscore buffer. This Z pin. And what are the master cell we have? Buffer and this. Okay. We will check where is this cell. Change underscore selection. Underscore net. Oh, sorry, cell. Get cells. So if we go here, that cell is added here. So just on top of that. If we do nets, okay. We have to specify the nets. So this is newly added cell. What it has done is like instead of this buffer has 60 drives. From this it has gone to this. Now it has 60 drives. So what I do is like select only this pin. Get underscore selection and do this. So we have the fan node. So insert buffer. So we can add for multiple buffers we can add. So like for some set of input pins, we can give all set of input pins and add it to this pin. Like after the first buffer we have, we'll add one buffer, and to that buffer only one set of pins will be there, and remaining will be like this buffer only. So that's how I'll explain. So maybe because buffer routing command is not working. So I'll somehow make it okay, divide by the noun. Okay, we have this also. Divide by denominator. So event number of cells, iteration, location, number of nets, distance, port distance. Okay, we have this command divide by denominator. We'll check what it will do. This option is abused the add buffer instead. So the design out. Check. This command adds buffer input. All except yeah. This is how we need to do. So normally we have like this. So we'll add that ECO only here to this like to one set of fan out. So we need to have the option. Space pins on the nets. Oh, sorry. Now I understood. So we need to insert underscore buffer on
have that list now. Where is that list? Sorry, history is gone. I'll do one thing. So we have all this control P, control D. Get on selection. So we have all these cells now. So what we'll do is like now I got the point. We'll empty this first. We have one more gvim pins.txt. So this file we have now. Based on 15 I'll somehow I'll randomly divide this. So for these pins I'll add one buffer. And for randomly for these pins I'll add one more buffer. Sorry, I just forgot this. So now it is like buffer is now. So we have one buffer and all these outputs are connected to that buffer itself, Z pin. So now what I'll do is like I'll create I'll add a buffer to all these cells. So before that I'll show logical design for this. Okay. Sorry. Here it is set. So we window. We have the schematic where it will be man. Anyone using this ICC recently? Oh, here schematic view. Net connectivity. Global routing. We'll have schematic here now. Analyze logic connectivity. Yeah. Oh no, not this. What I can do right click. I need to close this. Not I think. View net connectivity. No, not connectivity. Schematic window option will be there. Okay. What is the cell we have added recently? So this is a cell. So this is the cell we have and we'll have schematic. I'll show just a minute. New window timing interactive timing but here plan analyze logic connectivity. No, not this. Exit in view net connectivity. Not this. Schematic will have design browser in encounter design browser. Okay, whatever it is. So if we highlight this pin, let it be. Control Shift P. If I do this on this Z pin, if I do Control Shift N, so we have these number of pins connected to this. What I'll do is like add a buffer, some X buffer, and I'll split this in like a thing. So what I need is like insert. So insert buffer we have already used insert buffer. This is the buffer name and the pins are we need to give all the pins we have. So these are the pins. So we are specifying for these many number of buffers. For all these pins you add this buffer. So if we do enter now, so it's done. So it has added this open. We'll do. This is 1 2 3. So we'll check again select this pin, control Shift Z pin. If you do control Shift N, so still it is going to 60. Where is down ICC? Okay. So now it is 47. Previously we have 16. Now it is 47. So we'll check what all the buffers we have added. So here we have the full name. So this ECO cell is there. We'll select this cell. So where is that cell? So here is a cell. To this cell we have added. So now we have 47. So we have to take even more. What I'll do is like same as the previous. So insert insert on buffer, and the pin list will be this. And the buffer name we need to give. What is that buffer name? Remember that name? BUF remember that 7. So now we'll see on that. So change. I know what it is. So here if you see this is a pin. Previously we have 47 fan out. Now we have 30. So it has been reduced. So now we'll see what is the new cell added. So we have added this. We have added this. So and I'll split remaining three also. I'll split. So what I'll do is like insert underscore buffer, the cell name and BUF BD7. So now we'll check on that pin how many fan out it is. So I'm going to this cell, control L, have the list, select the pin, do control N, control P. Now we have 10. So we'll see what all those 10. These all are ECO cells. And you may say why there have been 10 cells added. So if you see these 10 cells added in different hierarchy. So this is in one hierarchy. 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 It has added in different. So I'll tell you. Hierarchy means in a module. We cannot divide netlist like we cannot write code that full netlist as a one module. In different like you know the blocks na. You know blocks na. Proc. Yeah, only one methodology. So in the same way, for whole block, we cannot code that whole netlist as one methodology. For a small things also, we have many like procs, many procs we have written. So in the same way, this is what it is like for some logic. Even in camera also, for initially when the camera it will take one raw image, further they will write one module. Next, so you will close the camera. But the thing is like before saving what it will go with that raw image. It will just have some like what is called. It will not have this color. Have random colors. Have already given. So it will have some random colors and that too like big pixels it will take. So all those pixels take and it will say background. We don't know. So further write one module and then create one more module where it will sharpen. Then they will create one more module where it will have brightness and contrast. So that's how it goes. Like different modules they will have. So the problem here is like whatever the cell we have is in the top module. If you see the slash declares a module. So whatever the top cell we have, this is the top module, and from this module it is driving a cell in the module in this module which is in this module. So this U1 is on module, submodule of this, and this is the submodule of this. That's how we call it as hierarchy. So whenever if all these are there present here itself, like this ECO cell is there. Suppose here it is itself na, then it will not add a separate thing. So one buffer will drive multiple things na. Here so one buffer we have given three hierarchies to add. We have random selected from 15 or 20 pins na. We have given that pins does not belong to only one module. It belongs to different modules. So that's how one buffer when it is adding na, it has to add on top module because it cannot directly add on. So I'll show. I think I don't want to use it. It is simple. we have a buffer in one module. We have a buffer in one module. This itself is a top module. And so we have sinks in one module, and we have one more sink in this module. We have one more sink in this module. We have one more sink in this module. So these many sinks are there. So a buffer, it cannot directly, we can add a buffer from this to this pin to all these modules. Whenever we are crossing one module, we need to add a cell. Or like hierarchy port, you can say later. It will create randomly port. Whenever it is crossing a hierarchy, if we go through lake, we can in there create a logical port. Which whenever hierarchy is, because it is in the module. So suppose this is B, this is C, this is E. It will be the module will be A/B/D. So whenever we are crossing the modules, we need to add one more. So what I have done is like I have given a buffer name like pin name from this module. Pin name from this module. So it can and cell name in the top module. These buffer, I'm adding a inverter from this buffer, I'm adding a buffer which is going to D module and D module itself. So it cannot directly go to D module and D module. First it has to cross this hierarchy, it should add a buffer, first to cross this hierarchy, it has to add a buffer, and this buffer will go to whatever we have given, and this buffer will again go to D, add a buffer, and it will go to E. And here the pin will be that's all. Whenever we cross a hierarchy, so there these many. So if you see here, like nowhere is common. Whenever we are adding, nowhere the hierarchies are common. You may see. You may say this is common. This is common actually. So in the first set of buffers I have given a pin name. What are the input from this module? And also second set of when the second set whenever I am adding buffer, there also I have given a input pin from this module. We got to. So the thing is like we have three sets. We have three sets now. So sorry. So these PCI core is there now. In first set PCI core. So in the first set I have given a cell name from this. In the second set I have given a cell name pin name from this module. So whenever I execute first command, it has added one buffer. Whenever I have a second command, it has added one more buffer. Because that net connectivity and the pin is different. So that's right. So for every module it has to add a buffer whenever I cross. Okay, you got this. But in the industry, mostly scales you cannot see. Even if you can see, also it has to go through like this. That's it. So for that I'll say how to check. So whenever we any command, the most important thing is like to check the log. So disconnecting. So this is the command I have executed. Sorry, where is that command? So instead of first we do is like whatever the name I have given now, some. So there is a buffer output, and it is going to all these inputs now. Suppose buffer, and it is going to 10 inputs. First time I have given these two cells. Suppose I have given these two cells now. What instead buffer is like? First thing it will disconnect these cells from whatever the pins from whatever the existing net. It will disconnect. Then it will create a net. Before it will create a buffer. And then create a net. And then connect that net to this Z pin. And that Z pin to this A pin. And this A pin to this one of the net exists. So these are three steps. So whenever you want to do manually, instead buffer it has done automatically. But in some cases you have to manually. I'll explain that. You can note that. Two things. Second thing.
Previously I said to note one. I'll explain. No, you don't need to know. Only one guy. Previously I said I'll explain some command. Add buffer.
Okay. So that's how. So we'll check the logs. So where is that? Okay, insert buffer I have done this. So floorplan loaded successfully. So it has inserted. It started in buffering this whatever the sorry reset net.
It is also a clock. Actually, this is also a reset. So it can have 60 fan out. But we have done the buffer. That's it.
So what it is doing? This is what I said. It will disconnect that
net from whatever the existing connections.
These are
whenever we have manual, the tool also does the manual things we have to do in a proc. That's it. Whatever buffer is there. In ICC or in whatever tool you use in this real estate industry, it is written in tickle. So that's like people learn the tickle as much as you can learn. Tomorrow I'll bring my laptop. So something. So insert buffer is also a proc. Add buffer is also a proc. Get cells is a proc. Change cells is a proc. It will have some internal commands. Why it is showing disconnecting net now? Because insert buffer is a proc. Insert buffer. What it will have is like I'm saying. So it can be logical based on my experience and all the things I'm saying. So the thing is like insert buffer fast thing is like we have
insert buffer and this all these nets and this buffer name. So what it do is like for all the pins whatever the pins we have given,
it will do disconnect. It will disconnect
net from all these pins and it will create a cell. If you can see. Okay. Yeah. This is disconnect and create a cell. Create cell.
It will add a physical cell. So this is a command. You know. One is disconnect net. I think anyone can note down that inside buffer these are all the things can happen. So that in future whenever you are working now. So whenever you are executing some command, analyze what that command is going to do. I think everyone is comfortable in Telugu. I'm saying it is not going as an interactive session. So that's what am I going as a practical thing only? Unlike from basic time, as you only have some comments. So in future you have any you can do like me. You can Google it or like help and see the map all the commands we have. So that's how. But it will like some practice session.
Okay.
So by default create I said now. It's a proc. That is not joke. It is really a proc. Whatever the commands in import or tickle, it is a proc itself. In that proc, it has some set of rules. What the rule is like?
For insert buffer,
we have remove underscore connection. Remove connection. Disconnect. Sorry, you know done. Disconnect is a command. Disconnect and what all the argument we give. That means the pin list we give. It will execute and then it will have create command. You can later you note down this command, but you later check how my analysis is because it will do the
steps. Then it is connect that net to what are the Z pins. So whatever the newly created Z pin is in, it is creating a net. It is creating a cell. So I said now it will create a net and it will create a cell.
Create net is a command. Disconnect is a command. Create net is a command. Create is a command.
And then connect net.
It is a command.
It will connect that to what are the newly created cell Z pin. Output. It will come from library. Check what the Z is also. So that it will connect. And it will connect the remaining like it is a hierarchy added. So it has created some hierarchical port and is adding. So by that you can normally later you can check this insert buffer, which is like why not crossing the hierarchy. So this and then again it is disconnecting net for all the input pin also. The newly added cell. So the input pin in like in this side and this end left and M. So it has to connect. So it is disconnecting and creating a cell. So like it is for newly added. So it is added 2-3 buffers. I said na. So here it is created ECO cell, and then here it is creating ECO cell 1. If you see, it has created ECO cell in the design. In which design it is created? PCI underscore top / PCI underscore core. Here it is created in PCI underscore top. I said whenever there is a cross hierarchy, it will create. So it is creating at this step and this step. So for all the newly created buffers, it will display and create a net, connect the nets to the inputs and outputs. So then it is disconnecting net for all the ports we have given. So these are the ports we have given. These all the inputs we have given. And to this input port we have like this net is connecting. So it is from this net it is disconnecting all these input pins. And it is connecting to the newly created ECO underscore net. If you see this is this module top read FIFO and FIFO CTL U2, and this is in U1. So first it is in one hierarchy. It is disconnecting all the input pins. It is I think everyone is understanding. So you forget about hierarchy. What creates
sync code.
Sync, not post. There is no one called pole hierarchies. Top down approach is like these are some technical words, but top hierarchy design and this core and top approach is different. So top down approach is using some other things. So not hierarchy. So don't confuse with some other word. Hierarchy means a module inside a module. So I explain whenever we are adding a buffer from this pin to somewhere in the module, it has to add a buffer every then only it can connect. So that's all. So what is doing? It is disconnecting net, creating net, gate cell, connect the cell ZP on A pin, and disconnect all the inputs we have given from the net, and it connect to the new cell we have, new net we have. It has created. So that's all. I think you can go through this log. Might be if you guys are not comfortable, please wait. Are you guys comfortable? It's okay. Then it's fine. Because I'm explaining only this create cell I have more than 10 minutes I think. But still question mark faces. Question marks are fine. I can repeat many times. But at least after 15 minutes or 10 minutes, I have explained 4 times. After then it will also confidence I can see. Then I'll stop that and go to next point. Or else I will being repeating that. So that's all. So we have done the buffer business now. Actually, the thing is like the command whatever we have now. Hey, you have linked now. Yeah, this create buffer tree. This command is not working. It is expecting some other libraries. If libraries it is expecting. The thing is like in ICC or encounter, one command will work as like such and one command will work such because these create buffer is enough for this create buffer. It's also a proc. In that they might have inputs might be required more. You can say create buffer will do what all the insert buffer has done. It can split some 10 or 20 LDLs it can do. But they might have like requiring particularly all the DB should be there. Suppose you can do trial route or some you can load the placement some left side are missing. But you cannot go through routing. And you cannot get the QR timing. So that's how. If we create clock, it is just simple thing. Last time I have gone through the timing session. So when I read the SDC, I'll read the SDC. I'll in that SDC only create clock will be there. And if I do report timing, will it come? Some other constants will be there. So in the same way. But if you do report clocks, it will work. Report clocks, it will work. If you do only create clock, and if you do report clock, it will work. And you may say report clock is not enough software, like why the timing tool is not timing. It is asking time will ask its own requirement. So in the same way, these might require compulsory the library should be there. I think what you can do is like from the link library, whatever it is asking na TSMC library, the CB13F, it is there na. CB13F20, TSMC, you remove that. That DB you remove that na. This command will work because it is asking that reference in that reference and target. That is if you remove from that folder and if you source again and if again it will work. ఎక్కడ ఉంది ఇదా ఈ కమెంట్స్ పనిచేసింది. అదే అబ్బా దీంట్లో ఇది జస్ట్ నిజానికి ఈ ఐసీసీ టికల్ వర్క్ అవుతుందన్న. టికల్ ఫార్మాట్ తెలుసు కదా నీకు. సెట్ ఇది ఒక వేరియబుల్. ఈ వేరియబుల్ టూల్ రీడ్ చేస్తుంది. సో అట్లా అనమాట. ఈ గ్లో స్టార్ ఏంటంటే ఒక్క నిమిషం చెప్తా. నేను చెప్తా సరిపోయి వెళ్తా ఉంటాయి. సో డాట్ చూసిన ఒక్క నిమిషం డాట్ ఎస్డి టీఎస్ఎంసీ అనేది ఉండదా? టీఎస్ఎంసీ ఓకే. అది డీబీ లోపల ఏదో డీబీలో ఉందన్నట్టు నాకు తెలిసి. యాక్చువల్లీ ప్లేస్మెంట్ స్టేజ్ కదా. ప్లేస్మెంట్ స్టేజ్లో ప్లేస్మెంట్ అయిపోయే టైంకి జరగాలి. నేను నిజానికి ఉండొచ్చు. ఎందుకంటే క్లాక్ రీసెట్ క్లాక్ దీనికని actually na that reset pin clock all this nets placement will not touch those nets. Placement will touch the data path. So at CTS stage only whatever the like initial stage na whatever the clock pin we have, that clock pin itself drive all the clocks in our design. So if some we have some 10K clocks, and in that 5K is driving clock and 5K is driving clock B. By default we'll have only clock port will be A and the net will be A, and this net is all the 5K cells. In the placement stage also it is the same. At the routing stage you can see some initialization jump. That guy will ask what if I should come from placement to CTS. So that guy will ask because of this. So that guy knows buffer will be added during the CTS stage. He need to know what are the buffer. So that's how the link is like. So it's CTS stage only. The reset pin or clock will be initialized. For clock hardly maximum 40, not more than that. But placement is not inside. So this is one thing. No, manually we should not. It will not by itself. It will not do. The if it detects. Actually, the thing is that if you open any library, dot.lib, if you open in the dot we'll have cell name and pins it will have. On the pin it will have a clock or sequential. If it has clock or sequential, placement engine will not touch that. Only the CTS engine will touch that. Either adding buffer, fixing the plan, whatever you do, placement engine will not touch. You any pin having in library pin is having like sequential or clock sequential only I think. Sequential it will not touch. So that's all. D will not have sequential. It will have normal. So that's why D pin. D and Q will be there. So data path only placement will analyze. CTS can have it can go
the players in scenes also we have a lot of commands. Create cities or cities. It can touch only the clock names, and we have hyphen XP option, and we have some other PSY in like ICC2 PSY option will be there, like placements. This is that can touch data and the clock. So that's it. Each and every command has their own limitations. That's why we need to read the man and we need to remember. So if you say create clock is working, and since clock is not working, means it has own limitations. It has own limitations. It's just a prox. It needs some arguments. It needs some permissions. So that's all. We just need to learn. I think this might be some high level things. I think based on the experience you can go. Yeah. So that's a good thing. So for now we'll what? I'll percentage you want. Yeah. Actually the thing is like we need to get lib cell is there. This is by default we have CTS min TSM. So this is the library name. Whatever here it is there. This is the library name. Normally in industry it will be like some RVT, like it will be some it with mass in on. But this is some like old technology I think. So it is just only we have only min and max. But normally everything even this cell name will be there. So here should have ln, but it is not there. It's okay. This library will have based on the libraries will based on PVT conditions. I think so whatever the libraries we have. So here we'll have PVT conditions. RC and then here we have ln all those things. For now we don't have anything. I think we have it is BD, it is FD. It is BD, it is FD. Some might have some fast and beaming. I don't know. Yeah, we can check in our design how much RVT percentage is there. Yeah. Cell names I'm saying na we can check from this command. So if you for a buffer you want to add an LVT cell. So what this command is in get cells. What this command will do, it will go to the libraries and it will in libraries will have macro and the cell name will have. It will search for macros. Macro and the cell name. If that cell name, if the star buff star matches now, it will report those cells. So in our design, these are the cells matching with the buffer name. So these are the cells only we can allow. So your question is how you want to know whether LVT is there or not in our design. So that is we have to see based on the naming convention. So some guys will use ln as LVT. Some guys will have ln. So we need to know that and we need to get it. Suppose if you want to know percentage, so we have BD. So suppose like assume BD has a high VT. So what we can do is like we can do get flat cells hyphen all and then what we can do is hyphen filter ref underscore name. So reference name with equal to star UF BD. So it will report only those like whatever BD is there na. Suppose assume as IVT or low VT. So it will report it. We can do size of collection. It will show 120. So in our design we have high 120 cells. If you want percentage, you can just do that. Control A size of collection. So out of 10,681 cells, only 120 cells are there. And later you can max I think. So percentage you can catch. So that's how. It's just a simple thing. Okay. Yeah.
Normally call slow, dip. What is this? Hey.
Corner high, HF.
Just.
Late cap, resistance. ఇది వీళ్ళు టర్న్ అంతే డిబిజీ ట్రేస్ నీకు ఎవరు తెలుసు డిబిజీ ట్రేస్ ఎవరు చేస్తున్నారు లేడీనా పేరేంటి జగన్నాథ్ నేను పడుకుంటాను సరేనా నిజం కదా వీళ్ళని ఇప్పుడు యాక్చువల్లీ ద థింగ్ ఇస్ ఇండస్ట్రీ సో సమ్ గైస్ విల్ యూజ్ LN as OVT and this normal and HVT and SLVT for supernovaty in Intel only two are there NN let's say and only two ways and like they have worked there no count in RHL it will have LVT HVT so that's all so there have own convention and in the columns also AMD Qualcomm say FF fast AMD will say fast and Intel will have H that's it so it is just we need to correlate that's it so that and the most important thing I want to say today is like it's okay now like everything it's like you can have understood everything now. So the thing is like I don't want to tell this negative open there. I'll show how to some voltage align today because we will have all those things. So we create some voltage align. They are some creating cells, tapping units, tracking cells, and creating units. So all those things we can. So that's my plan today. Anyone have any more queries? Anything should I need to explain? Power bumps don't take now. I'll say one day. Bumps now. You guys will go to industry and you will work as in block that's it. Block. That means one single. To see the bump is a high thing. You will at least sit for a year. To see the bump because now will get somewhere. So I'll explain the bump thing. Bump thing.
You want to come bumps.
Yeah, that's one.
No,
only that is not one count PNR. He'll just count only that bumps. Only that bump as an. So I'll tell you what the bumps like. So suppose encount open చేసిన encount innovation encount దీంట్లో open explain చేస్తా. I think you are okay with creating voltage align. Okay, let me complete this. I forget this. So the thing is like lips baby lips I standard lips technology file SDC and SDF SDF timing window files. These all are IEEE files. IEEE standard. Same IEEE standard ante 8 so whenever something is IEEE standard so every tool can load that. .db can load Redoc can load time everything even if any new came to industry. If he need to publish as some EDA tool, he need to follow the IEEE standards, or else he cannot make that. So that's all. So he has to maintain that, like he need to that format .db format. And all these things are timing window files. Mostly like no one will notice all those things. But I'm saying like based on my experience, SDC file, timing window file.
everything. What are the many files are there. All these files are ethical files. That's it. In a tickle format. So it's better. You learn tickle. Even in a counter, if you do some cell, it's a tickle proc. I'm saying this, so I don't need to say this to you like this much go into the article and say. I just saying to you because you just understand the comments. In life, somehow we need to understand what is right, all this same way. We need to understand what is a comment, what's the difference between like we can do. I have done create property. I have done. It is not exhibit. I have no need to give up on that. Okay, diffuse and we cannot do this. We need a ways. We have ways. We just need to find. And no need to sit on that. Okay, this comes. I'll make this only work. It cannot work. You just understand what it is required. It requires the .db. Now I need to go to the db and I have to remove the particular cell and then again I need all those things. I'll use somehow and then method. So that's even you also whenever you are go and started working. You find the ways. Don't do it one way. If one guy say okay, you do it this way, you do it and you learn that, you master it, it's better. But at least you need to find at least one more way for that. If you to find that na, you need to understand the tool. You need to understand the formats. You need to understand in SBC some error, not some error. We need to know whether we can comment that error or we can correct that error. We need to know. It's simple.
SDC last done చేస్తాం కదా ఒక నిమిషం డన్ చేస్తాం రైట్ so based on my experience I'm saying it's better if you learn that's it. So I have dubbed than SDC. So I have dubbed than SDC. Suppose I have given this SDC to you. And what happened is like these yeah normally here we have business na. That guy by mistakenly he has put square brackets. He has put square brackets. So that means you can see there he has put square brackets. So whenever you are sourcing the tickle in your like whenever reading the tickle in that, I'll save it and read it, don't worry. Remove under constraints. Remove SDC కదా సో ఇక్కడ మనకి ఎర్రర్ వచ్చింది చాలా సో ఎర్రర్ ఓకే ఇక్కడ ఎర్రర్ వచ్చింది ప్యాడ్ అని లాక్స్ కంపల్సరీ గో రావాలి. ఈ టికల్ కమాండ్స్ అన్ని ఎగ్జిక్యూట్ అవుతాయి కదా. సో whenever tool is executing reading these all these things na it will have some catch statement in like catch command in tickle. So they can use catch also in that like for reading a def na if it encounters any error it will exit. It will not read. If it is reading SDC or left na, even if it encounters error, it will put some catch to not stop. It will go to the next step. So at the end you may get okay everything warning only we can ignore. But we need to go all through the logs. So here we have gotten error on this pin. So that pin is whatever we have. So you are sitting here like expecting you sending to the lead and from the lead the guy and that guy to all those things. So you need to understand. This is just a command and that guy instead of floor basis he has put that. So that's how. Not only this might be small example to you, but in that industry you need to somehow understand that and you need to go. For each and every issue you cannot go to lead, you cannot mail. There are guys in the industry is like that. You find an issue, mail everything but instead of that this is the work way. This is how your manager gives some work to you. It has some issues. It will have some issues.
because it has some issues. That's why only an engineer is needed. Or else anyone is okay. So that's how in that manner you need to work. Everyone will work, but only guys can like make that work done. So you will be in that situation. So you understand the tools, understand the comments and the formats and the loops or CAD. I can maybe Tuesday I'll set up a CAD session so that we can do all these things loading automatically, automatically or like we can make a comment after planning. You can do a placement, you can do this, that. So that's how I can flow. I can set up a session based on that. Open that. Actually, the thing is like in all the industry. So whenever you are doing pump, so bump. So I'll explain about the pump. Let's start. I am like very anxious man. So started some things. So the bump. So you want to work on bumps. The new was now. Bumps. Yeah. You want to work on bumps now. So the bumps is like from the top level will get some power. So that power M1, M2, M3, M4 layers cannot extend the power. Even if you cannot like you can say why it cannot extend. However, it is in silicon. Even the M10 is also silicon. Even the M1 is also. The thing is like the way they are manufacturing M1 is with the small bits. You can ask why M1 is only small bits. They are manufacturing M1. If anyone asks like why M1 is small, can add M1. But whenever so the thing is like we need to have global access to the like pins and all those things of the cells. We have a lot of pins. So the M1 width is like 1 micron. It will cover almost 4-5 cells. Not even 4 cells. 10 cells of power. M1 width. So we cannot access all the cells. So each and every cell should sit at least 2 microns distance. Because 1 micron goes to this, 1 micron goes to that place. So that's how we cannot place all the cells at far distance. So that's how that's the reason why they have created M1 and which is and max which should be this. So if it exceeds we cannot access the ground level thing. So that's it. And the bumps is there. That's why even the top layers are high. The top level is even it is 100 microns don't care. All the conditions everything is done. So top level guys will give then create a bump shape. Like a point on the top of which they'll create a points. Not the point, they are shapes where power will directly come to that ports. And from that like later layer it will go on down. So the thing is in the red dog you can calculate. So again the red dog. It's okay. You try to understand for that. In red dog the minimum thing is like our voltage is our volt is 1 volt. You assume 1 volt. And our this can work at the worst case that we'll have some library characterization for standard cells. So what they will do is like based on the worst case conditions. With the 0 our voltage is like 0.1 volt is our target. Like what are the possibilities? But they will create the library of DB. On the cases we are getting 0.9 volts. Slow process and the AOC was not too much and the like the process also based on that they characterize a time range. So we should meet that library characteristics. Then only whatever we are doing timing on that, it will be perfect. I think you guys got that. So that cell library we have. That cell library power is this much and then timing. This is the timing. This is the cap output cap. On what basis he has done? He has assumed this cell will have this much OD, this much M1, this much power it will get. So it should get 0.9 volts. The worst case is like 0.9 volts. Suppose only we have only one bump from M10. It has to go to M9. From M9 it has to go to M8.
From M8 it will go to M7. And suppose the bump is here and the cell is here.
So these much long it has to cross
from suppose we have followed M1 like this.
M1 like this we have. And M2 like this, M3. So these resistance will be high. So voltage obviously voltage is different. Resistance is high. Voltage drop in those nets will be high. So whatever the voltage effect which is getting to this will be reduced. If it is less than 0.9, then what? So whatever the line giving is not correct. So that is the case why worst case is that. So worst case like whichever the case, like whatever the worst case then that is our worst case. At least we should need that. If we are even worse than that now, whatever the result we get is not good. So that's why. So bump as why they lot of bumps in the cells, right? At least that cell should get 0.9. So that's all. We'll have multiple points. We'll have multiple power states. We have multiple gas. So that short path, at least from any of the closest short path, it should get 0.9. Not less than that. So that's why we need the bumps and all those things. And the assay is just simple.
Suppose here I have one buff. Here I have one bump. And here I have one bump. And here I have one more bump. But in the middle it is failing.
In the middle, the cell is not getting 0.9. Resistance is high. Based on the resistance only we calculate. It is simple. Either we'll move this bump. What are the top bumps? Little bit down. Or the bottom bump will be top. Somehow to get that voltage. If it is not meeting, we'll create one more bump and put. And this methodology, you go into bump by bump are doing. They don't know anything about the voltages. They'll see. Okay. By 100 microns. Okay. Then that's it. If some guys say some issue now, they'll say okay, I'll create one more. So but why the bumps is placing, why the bumps are placed and number of bumps depends on these. So that's all. And bumps you have something.
To calculate straps.
Okay. Whatever the power we are doing, we don't. That is purely given by the chip top. So whoever guy doing the partitioning, okay, I'll explain partitioning. One day I'll explain the partitioning also. I think we have design today. I can explain also. So whoever guy works on the top now, he'll add his own power steps. He'll give one round of grid of power checks. And he's each and block is getting. In long go to stand level. He sees to the clock level. It's okay. This block is getting this way. And in dump a tickle file based on that. So the tickle file is there.
Suppose this is full chip and this is your block. Suppose this is your block. So wherever the nets are crossing, they are crossing now. He will dump the tickle and he will give it to you. He will give it to you. He will put in some CAD area. And whenever you run power plan, that's it is just a tickle strip. That's it. What we have is like create shape M10 from this way. This point to this point. Create shape from this point to this point. It will just add that M10 or M9. That's it. So whenever the top guy reads to like left now, it will be on the match. No short smoke, nothing. And the M1 M5 now, it is yours. It depends based on your block. Then guys will randomly put start mesh 0 or start mesh 1. The start point of the gym. So that's how like number of strategy. And probably he don't care about this M9 itself. So because even the block needs to you also some space will be there. So it doesn't. That's all. So power plant done. Power plant purely done by the top level guys. and he'll be to so we don't do anything. But in some cases there might be some voltage elements. I think the thing is like you guys have hundreds of things to say to you. So it started somewhere, bumps, timing, leaves, saturation, everything. So you guys tell me what you want. Like I have time now. I have patience now. And like at least I have some bit interest now. So you guys want to talk about what? And then if I start explaining, it will go to days. So what else you want? I can proceed with that. I'll say you all guys know like clock sections and how multi-circuit parts will be done, all those things. Because in the industry there's a fast question any individual will ask. So suppose I think I need a board or something. I need a board. I think. Pradhan. I can explain. You guys are okay now? With the feeling sleepy. So I'll explain. This is most important question. I'll explain it. You guys know that. You just need to focus on so props. So final set up so initially we have this I'll say these so this is so you all know what is the setup time. Setup time is like it is like is all we know. So to understand that, so whenever a clock launches the data, by default it will do it like the next capture whatever was to will go through also so these data will capture all things and hold will be done. Rule number one, we should not whenever any ask definitely this question you are going to face. Whenever you cross some like waveforms, and if we ask how timing is and what is pessimistic Okay, no, guys. I will go to one. So we know setup time, hold time. Setup time is like minimum amount of like this is the time which the data should be come before. Not hold. So this is the minimum amount of time. The data present before these amount of time. Hold time is the amount of time which should be stable. The amount of time. So I'll say you. So the thing is this. So whenever any asks, he draws this formula. Tell me how the floor can hold the board. Suppose a single clock is doing this clock and this clock. A single clock from single port. So we have first go to capture clock, and we have to see capture clock rising edge. And we just need to say the edge before this wherever it is rising the launch part. Not based on this. Based on this we have to catch. And based on this
at this point, wherever it is launching, the corresponding capture is carrying on the code. So that's we have this. So this is a normal way of reports, and you can see that whole report will be whole report will be like starting from this point. Second report will be like suppose clock. Let's start from this clock. It will go to buffer 1, it will go to buffer 2, it will go to launch and this data and capture from queue. And here clock like this is launch and the capture is just clock buffer 1 and buffer 3 and this these are flaggers. So you make sure you learn this. That guy learns from there the path starts. Don't be so suppose if it is okay, it is in the same domain, like the same clock group now, same clock coming from one point, and suppose if we have fast clock, slow, so whenever so this is the original clock, and this is generated is divided by 2. So suppose it is like this. This launch, this capture. And explain me the most simple way. So that guy will ask. So this is the timing part and calculate the time. How the tool does prime time. From where charge. Assume this is 0, 5ns, 10ns, 15, 20. So this is so how will calculate? Does anyone know? At least from previous what I have said, we need to first select what like first edge of this capture. So this is the first edge of capture, and this is second edge of capture. So by default it will go like this edge has to capture something. So it will say okay this we can go to I'll say so here is the launch and corresponding edge is launch is this, and by default the whole check will done before this edge. So whenever a positive edge positive is running, so whenever a positive edge does just before the positive only whole checks will done, not somewhere the next before the positive. That's so this whole check will done. So this is the first part. So what about this? Here also what we does whatever the launch where the next wherever the launch clocks like launch data closest one is this. So this is the same way. And here it is done, and the whole check for this cycle it will be this. So whole value will be this. So from this point whole check it will be a validity. So in this case you can say this is the setup check and the whole check. What about this? This is not a valid part. Or it's like whole check will be fair. So we have to accept whole check is fair. So what about when the data is fast? So what about this? In this what will happen? So same as this what will happen? Where the time or is the time. Fast we have to go to capture slicing. Capture slicing is this. This is also capture beyond. So this is capture slicing and just before like where like the closest launch clock rising. Closest is this. So this is the way the capture will done and the whole layer will done. Same. Whole check doesn't care about the capture. By default, when it is done, it will go to back. So whole check will be done like this. This is home. This is setup. So this is I might have explained in a simple way. The thing is like the big things has to be explained in a big way so that people can think and you can remember. If I say like you might think like definitely anyone like all of you training you would have things more than so it is not simple. If I say it you might think oh this will or like oh this is I'll not remember this. Don't do like that. Have done on that and like based on that have prepared a short note for like so this is what it does. So in this simple way either no one can explain. You guys just know. So what about multi-cycle tasks? So we'll go here. Here I have done because whenever you are doing that, you should remember. So so when I do set on mode to second. What is it? About this multi-cycle. So by default to go and read manufacture each and every for the grade for LS create and go from insert buffer. It will have some its own limitations now. When you learn those limitations, you know your limitations you can learn. So in the same way, you read the manufacture and know their limitations. Even multi-cycle path has own limitations, its own time problem. So what cycle path is like by not the default one, it will calculate the second edge. It will take the time in second edge. So this is the first. So it will take the second edge. For launch block is the and the capture block for which yeah capture or launch it doesn't matter. Between the capture of launch which there should be minimum 2 cycles. So in the same way we calculate here. By default setup here. The reference call is this. But this will be one. So we have to have two. So we have to go back. This is the point like I'm telling how the people like or what do you do or some coaching they will say go to decide capture plot. Why I need to go there? Just because if they cannot all the things that's why even one they are there for it. So go to the capture capture plot and cycle back into it. That means assume these are launch and you want to go to cycles and always to pair what capture because there is the capture and we need to this might be a simple example. This capture block need to be more in these cases. So the first step we need to check. We cannot check what is on this. We need to check the first capture. So that's it. So we have to go not to go to. This is the first one. This is the second one. First is two. By default, if you set one, it is by default itself is one. So if any gas, I'll do set one set. What you have to you can say on. So this will do. So it will be launch here. And you know the patient. So this you can love. But what about the whole? So by default two calculates one second. By default we will go one. So if anyone asks, I'll do second path one hold. What will do? The first thing you will do is whether you have to ask whether you have set one sec two on that like setup or not. If setup you have not specified now, then by default setup for one floor, one and whole will go back one step back. So what? So now the default is here. The default code. So and default one it will start 0, 5, 10, 15, 20. So during the setup then we will do launch at 0 and then capture at 20. Here it is. And for the whole what it will do is like launch at 0 and capture at 10. And the remaining is bottom same. Only this block is any so from this we will on and solutions. So it is a huge effort for it cannot make that whole time because there is some whole time there. The data shows for this person, but data can change. It has one clock cycle. So whatever you find more than service is analyzed. So it is not when we do when you do one I can't what we do is like setup it will some before it was 20 because we have specific. But what we do is like this is a default one and it takes 0. In setup I start with 1. In whole I start with 0. So that is what we do. So from 0 to 1. So this is here. So launch is so now is what is that's it. This case capture guys understand. So these are and I have setting one instead of so I will have the same so it will check what about the code. Yeah, very old time by default one step before so in the same so what to do is like so what we have to do we have to go back one again. So when it is okay you can understand. What this is what most thing. So now it's like someone said you have done. What is like instead of me is this one set up one do this one. Setup default back second back. So same set so it just once out okay ఇది సేమ్ అనుకున్నా సో ఇక్కడ రైజింగ్ హోల్డ్ సో ఈవెన్ కూడా ఫస్ట్ కేస్ ఇది చాలా సో ఇక్కడ సెట్ ఇక్కడ రైజ్ సో ఇక్కడ లాంచ్ క్యాల్కులేషన్ okay by default and when we set one to calculate from here. So even this is okay one thing. So if you do set one second to so here the data has to go back no ikkadi jagutadi చూడండి so here when we shift the
capture flop itself. So we don't need to this. We need to shift the capture flop. Like instead of whatever we are doing based on the launch capture launch flop, we are shifting. This is the one. So we are doing this is one. We are doing this. But in this case, so this is where we are capturing, and for the first cycle, we are capturing here. If I do like this is the most specific to do. By default we can most specific. But what we have this data only. We should not pick this data. You got my point. So if we don't do any segmentation by default, this is the capture edge and this is the launch edge. Here we need not to shoot the next clock cycle, because as I said every time we need to based on capture even if you go here on like this launch it also here it will take this will is pass. So here what we do is like every time we are doing capture edge, here we need to launch edge. What we do is like we need to set multi-cycle path icon start. The start what it is like instead of moving capture so whenever we are launching data, this it is ready. Now default is this. Default is what it is this it will make us this. So if you put start now to make this. Instead of if we don't start what the data capture here, instead of this cycle it will go and capture here. But if we are gathering between these two, but the worst is the whole will be calculated here. So setup will be here, the whole will be calculated even if you set one so to understand what we need to do, we need to stay these as this only, but who should that? So for every two block, whenever it is capturing, it will shift two times. Here also it will shift two times. So whenever it is capturing, it will not the immediate launch check back. So this icon start to give only from fast to slow. Fast launch to slow. So this out. Helpful. So even one. So whenever we are segment cycle partner, what is doing is capture flop. Instead of this, it is taking this. So default itself is this. So whenever we are data here, take this only. Whenever we are data here, take this only. So this slow to fast doesn't be that much. It's a segment cycle. Only we have to check. If it's segment cycle instead of here. So initially what it will do for this launch take this and it will check this old. But if it's this now it will go to this and old will done this. So we need to put again. Old we need to move. For setup it will be added only this case. We need to specify star. It is made that don't capture the launch itself. So these I'll make a response. What here I have done? Here made launch standstill and I have no process. Even here also I have made a response and I have moved launch it. Same thing I don't specify na. Launch I will constant and I'll use this 1 2. We cannot calculate here. Tool we can specify but the tool will calculate only because do this capture what the tool there are two things. One will by default whenever it calculate you will check minute thing. But we have specified check multi-cycle. What will do? For any capture, even from this also, this capturing from here or here. What will do is like from here it will go to capture forward. Even from here it will capture forward. If it is here, one they can next to this two. So that's right. But that should not be the case because it will go for the number. This you can go from 1 to 2. But thing is calculated. The report what is this? Set multi-cycle path. I said na everything has so limited. Set multi-cycle just shift it. But what is the problem then? Tool is whenever capture it will go just before the capture. We are say tool that on the line. Here it's okay. Here and here it's okay. Here don't shift. You even if you go on also there will be some shortest steps. Don't check this shortest steps. Check for the next shortest. So that's this is the most important. I think anyone has raised an incident. Anyone has all these questions. Not yet. Don't name is why this not in sense? Because it is specific. Now it's simple. Suppose there is some IO path going. It is coming from IO path. There might be some dependency and it cannot let into some thing and it is just simple. So there I have said now this thing. So this is from one CLC2. So this is slow. This is fast. So we can time as it is. Limit sections. This slow, fast. So it doesn't asynchronous timing color change non different. So synchronous so stay to the synchronous like between synchronous checks like asynchronous pin it will not at the timing. So whatever time you get detected, it will calculate in four simple steps. It will take valid endpoints. Valid endpoints. Flop in IO port or stop pin, all those things. And valid start points. So flops all those things. And there is data from valid start point to valid end point. And only wherever the flop is going. So if it is going then only it can. That's all. And we remove the same as then hops and just so suppose capture was launch from image. This was image. So the timing what you want to do, it will take the timing here. So I said timing is what is capture and wherever it is capturing, we'll check the recent data first launch it, closest launch it. So closest launch it, start. And the whole check. Where the whole check would happen. Then the mistake. So the thing is like on the same edge, hold and check. So what is exactly go back? So one cycle where the capture is going on. So there only it will calculate. So wherever it is coming down now, here it will here it is not calculated. One thing. Timing like state rules will calculate on the points like edges now only activate it will calculate only at the activate whether it is positive or negative. So here activate no it will not calculate and our theory is like it should be one code this. So it should be one. This is edges before but this edge is not active only this is active. So will go to this. So in the same way, if this is reverse. So in the same, his caption calculate. That's it. There's the things now. I think you can learn from also. So whenever we have a time, so in between these time parts, we have 100 of plus 1 we have slack. But here we have minus 500 PS. So what we can do? We cannot do any here. We cannot do any this part. So whenever we are getting a part, actually I'll give one session and time budgeting that. But for now, so this plan is we make this plan. So that means in this part we need 500 PS of delay. So that's but somehow that data is not very fast. So it is like 500 PS. So the data is launching here, but the data is coming at this stage. This is discount, but it should come before this. Even the setup for before this is but clear discount. We cannot fix this data part anyway. Then what we can do is like suppose we cannot make this clock a little bit closer. We cannot shift this clock, but we can shift this clock. Like we cannot do data part. We can shift this clock up this clock. If we shift this clock a little bit here now. So then the data part can be inside. Or if we move this clock this side, we can get here. So to move the clock, what we need, like in the diagram itself, if here it is not meeting now, it should come here. I will just move it. That's it.
This is one skew.
Yeah. Screw is useful. So we have to screw. Positive one reload current. We are using screw to fix the time. That's all useful. So either add what we have to do here. Either we have to add delay these two. That means the buffer we have to add. Or remove the buffer. That means make them a little bit backside. So either make this back or add buffer. So you buy for buffer or you add a buffer here. So that's how clock should go. So the latest is so this will be like suppose here before this it was 1, 2, 3, 4, 5 500 to this and 200 to this, and now what it has 400 to this. If you don't have 1, 2, 3, 4 and it's going to here 400 to this, and this buffer is adding here 1, 2, 3, 4, 5, 6, 7 to this. So we have got 100 PS delay cost. So like we add one more buffer here. If we add 4 or like one buffer which is to this, the cost should change. Instead we have a lot of skew. First thing the concept it's okay. You just done what you have. You go static and pass. One thing I'm saying with you, unless you read, no one like teaches you, and no one is like anything. You have to learn, and don't think okay this is the bar and go to this we should go this we should have fun friends don't think that. We have something to do. You do your work, and remaining rest of things leave it to the Lord. First thing is we have something to do. You do that 100%. And next what you want. Don't set false path disable timing. Disable timing is our range. So disable timing we have set. I think decision. We run. I think we go to and you go through all the logs. You go through only once in your lifetime. So you spend a lot of time in cricket. You spend a lot of time in going or having all those things. In your lifetime, only only once. Maybe after 1 hour. But what both plays only in your lifetime once. No. Serious law. Jevas and command five is the most important thing. Because and man is saying what the initial buffer will because I'll teach you something how to make it. So you just put little bit effort on that. You don't think like I'm putting more there and all those things. You like those things. Okay, I learned the CTS part. And now I learn this. That's also very little bit. Unless you learn things, no one will make it. Set false path is simple. So we can set false path from suppose we have a clock. So we have one slots. We have a max. It is clock 1. It is clock 2. And these are set buffers. So like this we have, and there is a thing. So worst case, either 0 or 1 it will be. Either 0 or 1 it will be. Suppose there are timings in between this. Suppose this is the model, there are different timings. So if we see physically, we have a path from this to this. From these clock as a launch shot, and this clock as a capture, and these clock as a launch physically we have, but logically either 0 or 1%. You cannot have paths in those things. You can just say false path, clock 1 to clock, and from clock 1 to clock, and from clock 2 to clock. Both units or else like not pin to pin. From clock 1. Get this suppose clock 1 to clock and from clock 2 to clock. So all the same. Instead of this, you put disable timing. That is what was set disable timing. Not R. Set disable timing is a command. What it will be like? I know the arcs. Arc is A to Z, B to Z, 1. So in the arcs. So there might be some cases where one brainless some marks. From A, B, Z, and yes, for this selection pin, he has put 0. Set case and so all this will go. Then no of 1. But some reason he has put. Or maybe function it is like this. Scan mode or something like that. So here, what he can do? So there might be some like this. So here data in funk mode. In funk mode, this is one. So there can never be funk mode is 0. So there can never be a B2 0. So he can set up B2 Z, set disable timing to B2 Z. So iPhone through there might be hundreds of slots here. There might be hundreds of slots here. Whatever timing path going through this path will disable. It will only go through. In the same case, set from clock to Z. What it will do is do not take clock to set. It will only take all it will. So this timing path is disabled. So this is and in between there might be hundreds of flops. Suppose we have a mark like this one, there might be hundreds of flops, in between we have a path. But because of this, it will not happen. It is like time only the worst case we need to set time mark. When we know 100% it can happen. Like I said, fun mode can be 0 and scan mode will be 1. So in fun mode we can block and scan block. But set timing, I think set timing, set design related. It will fast, it will take all the clocks, it is going to and then it set timing false. So that's what I said. So you need to understand the command is set code, set timing. Yeah, this is the So set visible timing. Internal will concept call. Dynamic test for analysis. So dynamic analysis. After Rega will do all the analysis. And what will after the so what so why we are doing dynamic analysis? So I say every single cell showed some 0.9 modes out of 1 mode. So when static error mode is like when it's not switching, just to calculate the stems from the top to very depend. And BSS pads to BSS bounce to BSS pin. So it will add and can by default, static is 5%. Static is 5%. Dynamic is 5%. So it's all for dynamic is
This is what you have to layout for that particular buffer. ఈ buffer కి layout diagram మీరు ఏమడిగారు అప్పుడు ఇక్కడికి
కాదు
మరి
మామూలు బఫర్ కనిపించి దాన్ని కరెక్ట్ setup and hold. We have to do clock getting cells because clock getting clock getting కూడా and or latch clock getting ఉంటాయి. I'll explain clock getting. Time borrowing is that's what I said. In a latch it will have time borrowing.
Tomorrow class start in 1 o'clock. Tomorrow morning 1 o'clock.
He said that is stop now. You can use buffer. You can do what no, like If we increase the length, chance of more. If we increase the width, chance of length, we are still adding the antenna is like whenever they are manufacturing stage. What is like first they will use one silicon itself, and then they'll go with the chargers, they'll make semiconductor. So when they are as a connector, so whenever they are adding doping, so they will speed beam on that, and those the electrons come and like sit on that. So the thing is like in silicon we don't have free electrons now. Only few we have. What doping like just adding one extra electron. That's it. So they will add that. So it cannot be it is not putting in that. We need some energy to go into that. So that's why it will go and like hit hard in the term like in silicon. So fit it to that. Feed the gaps on that. So at this stage, some ions will be there, some atoms will lose some or but the higher thing is this. So when they are hitting hard now, some atoms may get ion, some gas and atoms may get lose energy. So they may lose gain the electron. Then if number of holes are equal, then what it will become? It becomes become ion. So it will just either like negative or it will become neutral. So if it has added one extra what is called electron. Then what we have? It will become a negative charge. If it has like it loses the electron means what will have become positive charge. So this positive charge charge if on this rail positive charge are being applied like this, then what will happen? It will become open because it just it will not pass through. If it is negative thing na, then it also become open. It will pull all the positives and negative. So that's how. To reduce this, if the length is more, the charge it may reduce more because it finally goes to that. The charge is the charge value. If the number of positives are more than negatives are less, it will induce some voltage difference, and it has to go in gate levels. Our gate we are giving some voltage to maintain the gating. On top of the gate, it will add this whatever the charge by default it has. So then the gate may get damaged. For 1 volt it takes 0.7 VT. Because of that this charge will go to 0.9 and gate what is it called? Poly damage. So that's how. So increase the will no net crosstalk it will reduce.
Increase the width.
Crosstalk will be reduced.
Again.
Definitely window the spacing there. You have to have all the CR6. Then without antenna you want to put then it's you want to you can the diode sensor to add buffer only charge. That's it. At IoT you are getting the center in the center. You are some partial blockage in the center. You can put some bonds because there might be some hundreds of cells. So you have to explain this like in simple steps. So the question is simple, guys. So in placement stage we don't have any navigation in the design, and we have done the placement, and still we are condition the design in the middle, and we have IO ports, one 10K or some whatever it might be. So it's just we need to understand our design. There might be chances. We have 1K of IO pins here, and remaining 9K of IO pins here, and these both have communication. What the module will do? It will just split like this. when the module happen, lot of buffering. It should add buffer for all these timing fixes. If the timing fixes buffer is added, then more bits will be added. It has to be routed. And there might be 1K or 5 pins here. This module might be big like this. So it is also crossing in between. Or else like some more IO pins are here, and this module is between these modules. Then what will happen? In center definitely it will happen. Suppose worst case, there are IO cells, and they are sitting nearby because of this modules. AO cells are sitting here, and it's simple. So we have AO cell. This port has to communicate AO cell, one of the pin, and this port has to communicate one of the pin. What tool will do is like these are 9K. What tool will do? It will place it here, and it will add a buffer here. For this pins, one buffer and IO cell. For this one buffer and IO cell. And it will place some 10K of AO cells on the center. AO cell will be small, and M1 already packed. So we have all the cells to put. And if one is used, then again like for the other pin we cannot use then into we have M3 we have to write. And for the other pin we have to take it. All this gamma will do. For one cell itself, almost like 4 times of area is blocked. Respect to DRC. Respect to P. If 10 cells are present, then how much area? 4 times of the definitely DRC is will come. So that's how condition no other solution. Or else you ask the owner to shift this to here. No. Or this guy to make all your cells into and or ask designer to give more area. Or ask the guy to remove the file like space is there is rule. Or ask PVD not to report. HPG హై పర్ఫార్మెన్స్ అది మనకి ఏం ఉండదు డిఫరెన్స్ ఏమి ఉండదు. ఇప్పుడు 14 LPP దాంట్లో లో పవర్ యూజ్ చేస్తాను. ఇప్పుడు పలానా 14 LPP చేస్తాను. దాంట్లో లో పవర్ ట్రాన్స్ఫర్ చేస్తాను. సో ఈ LPP వాడదు వాడకపోవచ్చు. LPP వాడదు. హై పర్ఫార్మెన్స్ డిజైన్ 14 HP హై పర్ఫార్మెన్స్ వాళ్ళకి అంటే పర్ఫార్మెన్స్ అయి ఉండాలి. సో లో బిట్ అల్ట్రా నాయిస్ వాడాల్సిన వానికి ఆ టెక్నాలజీలో జస్ట్ నీకు ఎక్కువ వస్తుంది. సో నువ్వు పవర్ సాక్రిఫైస్ చేసుకోవాలి. రూల్స్ జరుగుతాయి. ఎందుకంటే VR కంపల్సరీ ఇంక్లోజ్ ఉండాలంటే ఆల్రెడీ 0.4 ఉంది. నీ VR పడతావు, నీ VR సైజ్ ఉండాలి. నీ VR నువ్వు ఎంత చిన్న కరెంట్ అయితే వెళ్ళాలి. ఇట్ హ్యాస్ టు డ్రా సమ్ మినిమం విడ్త్ అండ్ it has to enter metal. So somehow so we can reduce whatever the times we want, but we cannot reduce the VR because it is from one layer to another layer. It has to cross the current. So if it is this minimum na, then we cannot expect like normally we are expecting 4 cut or 2 cut. Worst case we have only 1 cut VR, and that is not manufactured proper. What will do? That VR is not manufactured. What will do? There is no current from gone. So worst case the current example is only. So what they are just because of the yield, instead of making one cut they are making 4 cut here. So then 4 holes has to be there. Obviously we will increase. Obviously we have to enclose that. Lot put cloning అంటే so guys one thing so same assignment so placement thing you have given and do cloning. I think that should not take even 5 minutes of your time. Do clone. How we need to that's it. you can create a cell parallel to that. Connect whatever the like we have cell A, parallel create cell B, connect this for this B, A pin connect the same net. Whatever A pin is connecting A cell is connecting A pin that net connect, and for the B output pins disconnect all of the cells here. What input pins. Output of these disconnect all the input pins from that net and connect it to that's it. That's what. Do what? I'll that's your wish. Whatever the time like so you are fixing the timing. You do whatever the launch. Ultimately PV showing DLC showing reduction train CLP that's it. RD.
Intel flow.
different flows. Company
Then you may explain what so that's it. I don't know what we are
All the companies supply on the Intel separate flow where is separate.
Suppose
flows ఇంకా వేరే something. Actually the same Intel we have server group HPG group SOC we have. So the managers are different, the employees are different. Manager and they have their own and these guys will not involve in residential work. These guys is not involved in this guys. And all these groups have their own CAD. All these guys use their own CAD source. Someone use someone ICC, someone is there, Pandora, someone is maker, so up to do. So is this class okay? Like guys understood? Path groups? Functional create. So how to create bonds? చెప్పాలా హిస్టరీ నాకేం తొందరలేదు అసలు నిజానికి బట్ ఎంతసేపు అయింది You are learning online commands. It is showing how to read the command, how to get the command and how to recognize skew grouping. Instead of this ask me something like manual routing. Manual also said na. So in the company we don't all these things. In company mostly is manual routing, manual things or changing create
We also don't extra.
Then how is he using this?
MS macros. Unlock macros also.
Skew is just saying that these cells should match this field. So suppose we have a bus, DDR bus. So we are working on DDR bus. So that is your ramp. So is one pin it has like we have the bit also put once. One bit came and clock next bit is coming here next. Is it okay? Whatever code we are getting that has some code and it has to be same way. So for that we need to maintain same meters. If we maintain same screw, it is automatically same screw also. That's why we ring all the 4 bit at once. That's all. For that we use or else I'll say a simple example. So there are one set of flops. They are communicating one set of flops. Their first part is like 100 PS, positive 500 PS. And these set of flops is communicating another set of flops. And here the timing part is like 500 PS minus. So we can use this. So whatever the used to said now, it is only for single buffer to buffer, flop to flop, single flop. Here some group of flops are there. So there we can say these set of pins, only this is there. So that calculates. That's how we can get these Q useful to this from this part to this part. So we can use that also. Any more doubts? Practical doubts? I don't want to explain anything theoretical. So anything you ask me in I want some placement options. I want some options online or last Sunday I want to say what I want and what I want. Then we have one discussion. But last what I want to say that reporting time is online. It will be 3 hours 4 hours. In today small company talks about this. The thing is like this, guys should practice more. You should practice. Whatever the steps have given. Maybe more along with session. You 3 or more. 4. Because that is the most important. The thing is instead of it is the flow and how to work in the company. I just want to learn CAD, and I want to make you write some small steps and small flow or some automatic flow after placement science. The placement is like this. Put this option. This option. That's what I want to all those things. Not science. Mostly I think it's better to go in that way. These answers even if you do 200 times also. That answer going to you or not, but just to for your happiness, for your satisfaction. So people will more and more make sure that before 10 you come. You would can go before 1, 2, and 1. Practice on the tool. Read from man. Hey, you guys are from let me do this. What's your name? Neela. Vein. Telugu. Himan. Ramesh. Madhu. You all are from like streets. How is Mirafta? They road training. Okay. How is Guru? Must time this. That means
Moneylo best. Moneylo best.
technical thing. How is training in You have like no ICC. You don't have ICC only one system. Chipet. How is
Batches are there. Saturday, Sunday.
Actually, like I'm planning to have this target to get training this show. So if any of you guys any requests now, so I can definitely it will be helpful for me. And I can guarantee you like I'll make them end to end all like not only process from partitioning synthesis like partitioning the synthesis and power planning routing and sign off CLP lake and this redoc all this and flow development. I'll make them to write the scripts flow definitely. So all the like subject is done. How many? It will be 4 months every day. I don't know how Sunday is in 12 Saturdays I don't think we can and all everything will be hands on and we have designs will be there. They'll have their own project and we have my own clients. So if you guys not fun, or you can refer someone. So it will be beta science. Beta science. Don't ask fees will be if you they say your name 80k. Madam, we are here all the redoc. You will get hands on DC counter ICC. In Hyderabad 3 lakhs. Are you very lakhs? 1.8 What? It will be conventionally. So many hospitals and one thing. So our institute will be like a corporate thing. So don't take anything like this. So it will be a corporate thing. Even whatever you are seeing in the office now. So the same condition there. Everything will be like standards and mostly like if possible like we have our own clients project. So maybe like in 3-4 months we are having it. So on that project that means no need of other companies. Mostly by what it works. And yes, technical things that's done. So I'll do 100% more than 100%. And not only on ICC or mostly somehow I'll get all the tools and all the hands on each and every person. And mostly at the computing like 3 to 4 at least 3 projects I'll train end to end 3 projects they have done. This month start. Yeah, by October 20. This month we'll start. Nine. Today is 5.
Right, this one. Minimize.